Welcome back. Today is day 6 of our triangle relationships unit. We will be developing a rule to find the sum of the interior angles for any polygon. Hope you enjoy the lesson. Alright, to start this off, we're going to take a look at what are polygons. So a polygon is a closed figure made up of line segments, not curves, in a two-dimensional plane. Okay. Not too bad. Polygon is a combination of words. Poly means many, and gon means sides. Oh, that's pretty easy. So what are the important things that we need to know here? It needs to be a closed figure. So this thing has to be closed. It can't be open. Like it can't be. It needs to actually like start and end back at itself. There is no curves. So if you have any parts of the figure that has a curve or a circle, like a semicircle, that wouldn't work. And it's going to have to be 2D, so that means it's going to be flat. All right, so it's closed, no curves, and it's going to be flat. So if you look at all the shapes below, we have a triangle, a square, a pentagon, hexagon. All of those are examples of polygons. And what you should notice is that each of them are made up of line segments. So everything's straight. All your edges are straight. There's no curves there. They're all closed and they're all flat. Okay, perfect. And again, just remember that poly, easy way to remember it, poly means many and gon means sides. And it takes a minimum of 3 line segments is required to connect end to end to make a closed figure. Thus, a polygon with a minimum of 3 sides is known as a triangle and is also called a three-gon. So that's pretty interesting. So a triangle has 3 sides and we can call it a three-gon. Remember, gon means sides, so that's like saying 3 sides. All right. And an n-sided polygon is a polygon with n is called n-gon. So n-gon just means that we are going to have n sides, that we don't really know how many sides we're going to have. We're just going to have n sides. Like a hexagon, for instance, right here, we see that it has 6 sides, so we're going to call that 6-gon. All right, a heptagon, pretty easy, is going to be a 7-gon. All right, but if we say n-gon, then we don't really know how many sides we have. We're just going to be a variable. It could be any number of sides. All right, so nice little vocab to get us started. All right, so this problem, I love this problem. I usually let my students just go ahead and attack this problem any way they can. I really want to see some reasoning here, and here's some of the kind of reasonings that I usually see. So find the sum of the interior angles of a regular hexagon. So our job is, first of all, before we even start, what does regular mean? Equal sides and equal angles. All right. So this regular hexagon, so that means I know in this figure here, all my sides are the same and all my angles are the same. All right. But the goal is we want to find the sum. So I want to know the sum of the interior angles, what all these angles add up to. So if I was to say like A, B, C, D, E, and F, what would that add up to? What's A plus B plus C plus D plus E plus F? And again, I usually let my students just attack this problem any way they can. And we know in a triangle, so what we know a triangle, if we added those angles up, those 3 angles, we would get 180 degrees. All right, but in this problem, we're going to, remember that's the whole goal. The whole goal for today is to figure out what does all these angles add up to in all our polygons. So let's take a look here. One way that students do this, and I'm going to do it a couple ways. One way that students like to do this is, I've seen this a couple times, is they cut this into equilateral triangles. So they notice, they're like, oh, this makes equilateral triangles. And when they do that, each one of these will be 60 degrees. 60, 60, 60. So they find the central angles and they're all, oh, okay, so each one of the central angles is 60 degrees. And now we know this is an equilateral triangle, each one of these. So this one is going to be 60 degrees out here, and this is 60 degrees, but then that works everywhere. So we get 60 and 60 and 60, 60 here, 60 here, 60 here, 60 here, 60 here, and 60 here. So when they do it this way, then they notice, well, A is going to be 120 degrees, B is going to be 120 degrees, C will be 120 degrees, and so forth. So basically, they're like, oh, this is not too bad. I just take 120 degrees and times by 6, because there's 6 angles. And so you end up getting 720. Perfect. All right, so this is one way that students attack this problem, and I love to see this one. This is beautiful. All right, the other way I see, sometimes students, and I saw this the other day, it was nice, students attack this problem just by decomposing this into a rectangle and 2 triangles. And then what they tell me is they go, well, this is a rectangle. Now they don't prove it, so it's kind of still informal. But I mean, they can still say, well, we know this is 360 degrees because it looks like a rectangle, and then they get 180, and they get 180. Perfect, and their answer is 720 degrees. So that's another way that I've seen them do this problem before. All right, and then I mean, and there's a whole bunch of other ways. And another common one is just some students split the hexagon into 2 trapezoids. So they're like, oh, there's 2 trapezoids here, and I know that each trapezoid will be 360 degrees. So they're like, this is 360 degrees, and this is 360 degrees. So that will make 720. So I've seen this problem done many ways and many different reasonings on how to do it. But let's go ahead, let's try another problem. Next problem, so find the sum of the interior angle of the regular pentagon. So by now, students have some ideas of how they can do this, and they start seeing really quickly that we can decompose these into just triangles. So in this problem, I'm going to see that this is 180 degrees, and this is equal to 180 degrees, and another 180 degrees. All right, and so that means my answer is going to be, since there's 3 triangles, since I have 3 triangles, I know that each triangle is 180, so that's just 3 times 180. And this is what they start doing by now. So now you should start seeing, oh, just try to take my shape and cut it into a couple of triangles, a few triangles, and just do a little multiplication. So I believe that is what? 540 degrees. All right, perfect. Let's try one more. Here's a heptagon. For me, it's a kind of an ugly shape. I don't know why. It's odd, maybe. Maybe it's odd and it's not symmetrical. Well, it's symmetrical somewhat. But let's take a look at this one. So if I'm doing this problem, how about we start cutting this apart into some triangles? Let's do another triangle there. Maybe we could drop another triangle here. And maybe we can cut this last one into another triangle like that. Perfect. So there we go. So I've decomposed this into 1, 2, 3, 4, and 5 triangles. All right, so I've taken this heptagon and I've made it into 5 different triangles. And now each time, that's just going to be 5 times 180, which is 900. So not too bad, you see? It's not too bad to do these problems. All right, let's take a look at the last. Now let's summarize. Let's analyze what we've been doing so far. Okay, let's put this all together. A pentagon. A pentagon, what we found was, well, a pentagon we know has 5 sides. But now, how many triangles can we create with the pentagon? And again, remember, these can't be overlapping. So I'm going to draw right here. I'm going to sketch in here. I can create 1, 2, and 3 triangles. So I can create 3 triangles. And then the calculation is simple. How do we calculate the interior angles? It would just be 3 times 180, which would equal 540 degrees. Okay, so not too bad. Let's try one more. So a heptagon. So again, how many sides does a heptagon have? Well, we know it has 7, but how many triangles do we create? I always do it from one point when I'm making my triangles to make sure I don't miss anything. And so then I have, let's see, 1, 2, 3, 4, 5 triangles. So 5 triangles this time. So that means this is going to be 5 times 180, which is equal to, what is that, 900. All right, not too bad, right? This isn't too challenging. So octagon, how many sides does octagon? Think of Octomom, she had 8 kids. There we go. And we are going to have 1, 2, 3. That's 1, 2, 3, 4, 5, 6. 6 triangles. So that means our calculation would be 6 times 180. And game over. That's going to be 1080. There we go. All right, now the key here, here's the key though. The key to this whole problem, to understanding what we're trying to do here, is to know the relationship between the number of sides you have and the number of triangles that are made. So pay attention here. If we have 5 sides, then how many triangles were we creating every time? We created 3. If we had 7 sides, how many triangles did we create? We created 5. If we have 8 sides, how many triangles did we create? We created 8. So every time we are decreasing by 2 we're decreasing the number of triangles by 2. So if you had 5 sides, you decrease by 2. All right, that's the key to this whole problem. That's the key for us to writing a formula for this. Practice says calculate the sum of the measure of the interior angle polygon with 32 sides. So you have some polygon with 32 sides. There's no way you're going to draw it, but you should be able to visualize this in your mind. So if we have 32 sides, that means n is going to be 32, right? So n is 32. Now we can use our formula to find the sum. So the sum is equal to n minus 2 times 180, because basically what are we doing? We're finding the number of triangles. So that's all we're doing, and then we just multiply by 180. So we said that every time, well, n is 32, so this will be 32 minus 2, which is 180, but you could have done that with mental math, just subtract 2 every time, so that'll be 30 times 180, and multiply this out, and we're done with this. 5,400. Game over. So if a polygon had 32 sides, and we added up all of the 32 angles, it's going to add up to 5,400. All right, let's go over here. If the sum of the measures of the interior polygon is 9,540, how many sides is that? Oh, this question is asking you to go backwards. So they want you to figure out how many sides do you have. We know the angle, so we know we have some shape, and the sum is going to be 9,540. So that's what we know so far. So we know this. So let's write our formula out and let's try to solve this. So the sum is going to be n minus 2 times 180. And we already know that the sum is 9,000. So let's substitute that in. Oops, back. 9,540 equals n minus 2 times 180. Now, this would be a great place to do some algebra. If you like algebra, go ahead and do it. I'm just going to use GeoGebra and type this into GeoGebra and get my answer. So my answer is going to be, it looks like n is equal to 55. Okay, but you could have solved this by hand, but I'm just going to use technology to do it now. So my answer for this problem is n is 55. I will display the code so that way you can see it, how to type it in, but it's nice and simple. All right, I hope you enjoy this lesson.